First, what I'll do is quickly I'll tell you what all things in this basic Python course we are going to cover. Okay, and then one by one each chapters will start with. Okay, so we have designed this course into 7 chapters. This basic Python, there's a separate course for advanced Python too. Basic Python course, I have designed it in 7 different chapters. The first chapter is introduction, in which we'll be learning about what is Python, features of Python, short history of Python, then how to install Python, and the elementary programming things like what identifiers, keywords, different data types, and operators. And then we'll be solving questions, programming questions. I'll be giving you some assignments, some trace output questions, especially which are asked in the interviews. Mostly I take that type of questions only. So that will be covered in this first chapter. Lot of elementary things. So as I said, like history, features, how to install Python, your first Python program, different ways of accepting input and sending output. And these are the elementary basic building blocks of every programming language, like what identifiers, keywords of Python, then variables, different data types, and operators. And I'll be taking lot of trace output questions. Don't worry, our intention is to prepare you for interviews, not for academics. Main intention is you will appear in interviews properly. That is the main goal. Okay, then the second chapter, that is control statement. This is heart of every programming language. Means no programming language is complete without control statement, because these instructions help us to solve many complex problems. Like lot of problems cannot be solved without this. So in this we'll be learning some conditional statement like if else, elif, some iteration statement, that is repetitive statement, looping. In Python there are very simple 2 types of loops are there, for loop and while loop, and some transfer statement like break, continue, pass and all. Okay, so all this will be discussed in this chapter 2, right? Again here also abundant of trace outputs. I'll take some exercises for loops and all I'll give you, don't worry for that. Then the third chapter will be the introduction to one programming paradigm, that is procedure oriented programming. Okay, till here you'll be just writing structured scripts, like you'll just write a sequence of code and that will get executed. This chapter will give you one programming paradigm approach, that is called as procedure oriented programming. Okay, and in this we'll be learning how we can divide bigger problem into smaller sub problems, and then for each sub problem we'll write a separate function, then we will reuse those functions, and lot of related topics like what are different ways of passing parameters, then scope rules, recursions, lambda functions. Lambda function maybe for some people will be new. Okay, lambda functions are there in some other scripting language like PHP and all, but those who know C, C++, Java, now Java also has introduced in the latest version. So lambda functions, all that will be discussed in this chapter. Okay, so library and user defined functions, some library functions also I'll take, don't worry. Lambda function, recursion, yeah, just an overview I've given, but actually when the chapter come, lot of other detailed topics will come, like argument techniques, scope rules, what are different scope rules in Python, all in detail we'll discuss, don't worry for that. Then another chapter is specially devoted for data structures. This data structure, many times in interviews it's asked. In interviews many times data structures are only asked, and data structure will be really useful for your advanced Python concept, like those who are planning to enter in machine learning, data science, their extensive use of these data structures are there. Getting? So data structures means different ways of organizing memory and then doing different operations on it. So the main 4 data structures we'll be discussing, like list, tuple, dictionary, set. And I have just kept one separate topic called string in this chapter only. String, and related to string, one topic called regular expression. And regular expression, practically it is again asked. Getting regular expression is also used in lot of automation applications also. Okay. Then comes another programming paradigm, that is object oriented programming. Okay, as I said, in this one programming approach you are going to learn, that is function oriented approach. How to divide a problem into sub-problem, and then for each sub-problem write a function. Here a separate programming approach where related data, related functions you'll put into one capsule called as a class, and then creating objects of it, and then they interact with each other, and then the concepts associated with it, like constructors and destructors, then operator overloading, inheritance, all that thing in one chapter. Okay, you can say, like, if you people know C++, it will be a revision to you people. Like lot of C++ comparison will be done in this chapter. Okay, so the basic things like class, object, constructor, destructor, operator overloading, inheritance, all I'll be covering in this. Okay, then comes one separate chapter called exception handling. Okay, exception handling will give you introduction to robust code, how we can write a robust script. Okay, so if you have some basic knowledge about exception handling in C++ using try catch, or in Java using try catch, same way here, but here there is no try catch, here it is try except. Try except. So we'll be learning in this exception handling, like how to write robust script if problems occur, how to handle those problems. Okay, so associated with that, we will be also learning how to write our own exceptions, that is user defined. I'll add some more topics like assert, like what do you mean by assertion, that too. Assertion in Java also, the concept is present. And then the last chapter is file handling. Again, file handling is very important. Those who are again planning for automation. So if you're planning for automation, file handling will be really useful for you people. Okay, so here we'll learn how to open file, how to read the data into the file, how to write data, and some associated things. Okay, so opening, closing, reading and writing, then dealing with directories also. I'll tell you how to deal with the directories and all. So all that will be covered in this last chapter. So this way, the basic Python course I have designed in this 7 chapters. Okay, so hope you got an overview. If the overview is clear to you, then we can start with the actual course, that is with the first chapter. Okay, so I'm expecting response from you guys.
Yep, all good.
Okay.
Yes, sir.
Yes, sir.
This is just an overview. Okay. Good evening, Sonali. So let's move to the actual syllabus then. So I'm happy that you have given me the response. So the syllabus is clear to you. Now the approach of teaching is, as I said, after each chapter there will be an MCQ test, which will be the part of evaluation, because at the end we have to give you certificate. So certificate cannot be given directly. There has to be some evaluation criteria. So at the end of each chapter, I'll be sending you MCQ test link. You have to appear for that. I'll be giving you PDF notes of each chapter. Don't worry. Whenever the chapter gets over, I'll be mailing you with the notes, and even some assignments I'll be giving you, which you have to solve. Some assignments we will solve over here, but some you people have to solve. Okay, that will be just an hands-on for you people to get comfortable with that topic. Okay, so based on each topic I have designed assignments, that PDFs I'll be sending once the chapter get over. Okay, so hope the process is, the Methodology is clear to you. Now what we'll do is we'll start with the first chapter. I'm sure you are excited to start with Python coding, but immediately we cannot start. Immediately with the first Python program. Some basics are there, some theoretical concepts are there, which we have to cover, and then only we can start with the Python programming. Okay, so first we'll discuss what is Python. Before telling you what is Python, four important terminologies are there that we need to first clear up, and then we will give a systematic definition for Python. Okay, now what are that four terms? And at any moment if you have confusion, because some people maybe have got disconnected with the coding and now after a long time you're coming back again, may happen. So some terms, if you're not recalling, you people can ask me. Maximum I'll try to cover it. Okay, now what are that four terms? So in which the first term what we are going to talk about, that is high level. Okay, so the programming languages, now I'll not go into too basic what is programming language. I hope you know it is an artificial language. It's not a natural language like humans speak. Okay, so it's an artificial language. It is the way to communicate your algorithm to the machine. You have some algorithm, but now you want to tell to the machine to perform that algorithm. So how you'll communicate with the help of programming language. They provide you with some set of instructions, and using that you will write your algorithm, convert the algorithm into program, and then you'll give it to the machine, isn't it? So all these programming languages, through evolution, they have not come in one day. Evolution, starting from 1950s and all, when first programming language came. I have presented one paper also on that long back means 3-4 years back. I presented one paper on evolution of languages, in which we did the studies of different languages from 1950. From 1950, how the languages evolved and how many are still there, how many have become absolute. Lot of study we did that time. So we did the classification, how the languages are in imperative and declarative category. So I'm just trying to tell you that languages have not come in one day, through evolution. So normally languages are first generation language, that is machine language, which is the machine's native language of zeros and ones, which today also machine understand its own native language. Then we have a second generation language called as low level language. It's also called as an assembly language, which today also it exists. Getting? But now we don't directly program in it, right? In the first generation, people only used to program in the native language, isn't it? In the second generation, that is assembly, they are the set of mnemonic instructions. Mnemonic instructions means symbolic codes for each operation. For add, for sub, for mult, div, set of instructions are there, and then using those symbolic codes we used to write program, and then using assembler we used to translate it. Then came the third generation language called as a high level language. Now third generation language is more closer to natural language. Natural language means language spoken by humans. The best one is English. So it is more closer to English. As we try to express anything in English, the same way we express in the programming language. Like as we write in our algebraic way expressions, or we in our English we give some conditional statement, if this, do this, otherwise do this, or do this till this condition doesn't become false. So as we are expressing in English, the same way we are trying to write in the program. So that is the third generation. So I'm not going into too detail, because I'm sure somewhere in your academics, in some subjects you have studied this. Here I just wanted to highlight on this thing, that is high level. High level means it is more closer to human language, or more closer to natural language like English. As we express anything in English, the same way we are trying to express it in the program. Okay, but obviously high level languages are more closer to human, so it will give human convenience. but ultimately you have to convert it into machine form to make it to understandable to the machine, right? So the second term now come into picture, getting that is interpreted. Now actually Python is not purely interpreted, okay, like Java. And remember, Java is a later language, Python is earlier. Java has come later, Python has come before. Okay, so Python is an impure interpreted. How it is, I'll come to it, but what is interpretation and all, before that we'll discuss. But I guess before that, what is high level is clear to you. So Python is high level. Why? Because it is more closer to English, or it's more closer to human spoken language, natural language. As we express anything in English, the same way we try to express in the program. Coming to the interpreted terminology. Now, whenever you write program in high level, okay, which is your understandable, machine understand its language, that is language of zeros and ones. So you have to make your language understandable to the machine. So you need to do some translation. Obviously your program is to be translated. So intermediate some system programs are there which are employed, and who is that system program? A translator, whose job is to convert your high level code into machine code. Means its job is first to check the errors if there are. Okay, if in your program there are any errors, it will tell you the errors. If not, so it will translate it into machine code, and then that machine code is given to your underlying CPU for execution, isn't it? So the translator are of two types. One is, I'm sure this two you know, one is called as a compiler, okay, and another is interpreter, and there is something called hybrid concept, impure mechanism. Okay, so one is an interpreter, one is a compiler. Both are translators, but both have different policy of translation. What compiler does is takes your source code, and in your source code it will check in the entire source code if there are any errors. Obviously syntax errors, semantic errors. It won't search logical errors. Logical error is the task of programmer. Clear? So it will check whether there are any syntax errors, semantic errors. If yes, so it will generate the errors along with the line number. But no, so it will translate it into machine code. That is called as a target code or executable code or a native code. And then that native code you can give it to the underlying CPU for execution. CPU will take that native code and line by line it will run it, right? But compilation policy is entire source code. It takes the source code, the entire source code, error is found, and no, so it will convert it into a native code, that is executable code, which is in a file form, and then you run that file as many number of times you want. Getting? So next time when you want to run the program, just run that executable, load it in the memory, and you can execute it. You don't have to do this translation activity again. This is compilation. So there are many languages who follow this pure compilation policy, like C, C++, old Pascal and all. They were pure compiled languages. Then comes interpretation. It is also a translation policy where it is line by line converted. It takes the source code and line by line convert into machine code and give it to the underlying processor for execution. But that machine code is never in a file form. It is only in the memory, and the CPU will run it. Next time again you have to take the source code, line by line converted into machine code, give it to the underlying processor, and it will run it. So these are the two different translation policy. Compilation entire. You get a target code file. You run that same file again. Okay, compile once, run any number of times. Interpretation takes the source code, line by line convert to machine code, give it to the underlying processor for execution. But here the line by line concept is there, and every time it works on the source code. It never generates what? An target code file. Getting? Now Python is a hybrid mechanism. It follows both the policy, impure concept you can say, pseudo translator, which Java also follows the similar policy. Okay, so I'll just try to quickly tell you. Okay, this we call it as a Python interpreter, but I said it is an impure mechanism. You will write your Python source file, which is saved as .py. Okay, you'll create your source file, Python source file. Internally, it is given to the Python compiler. Okay, what this compiler does is it takes your Python code and checks if there are any errors in it, syntax errors. If there are, it will generate it. No, so it will convert it into an virtual code, or you can call it as an hypothetical machine code. Means it's a machine code, but for a hypothetical machine, not for a real machine. Means you cannot give it directly to your underlying processor and tell, shoot, you start running it. So no, why? Because it's not in a native form. We call it as a bytecode. Okay? Now I'm sure those who know Java, they might relate with Java. But remember, in Java, that concept has come later. It is first introduced in Python. Okay? So what this compiler will do is it will take your Python code, errors, convert it into bytecode. But that bytecode is entire converted, therefore compilation policy. What is compilation policy? I hope you got it. Okay, it will entire convert it into bytecode. You can just remember bytecode is like a machine code, but not a true machine code, because it is not in a direct native form. It cannot be understood by your CPU. It is for some hypothetical machine. Okay. Now this bytecode, which in .NET framework, now those who know .NET or those who are from that background, there they call it as assemblies. There too the same principle is there. Okay. And then it is given to one virtual machine called as PVM, Python Virtual Machine. This is also part of your Python interpreter only. It is like your OS, okay, because it does lot of functioning of OS, like memory allocation and deallocation, then threading, scheduling, garbage collection, lot of activity. And one main role which this PVM performs is converting this bytecode to the actual native code. That is the machine code. And then that native code is given to the CPU for execution. You understanding? Clear? But is this PVM line by line going to do it? Therefore, here the interpretation policy comes, and therefore it's hybrid mechanism, a impure mechanism. So Python code, compiler, error, it will tell you no, convert to a hypothetical code. Now some people will ask like, can we see this bytecode? Normally in Python we are least bothered. We are just concerned with the output, but you can see it is stored in .pyc file. As like in Java it is in .class, here it is in .pyc. You understanding? Now this .pyc, which is a bytecode given to PVM, PVM will line by line convert it to machine code, and then that machine code is given to the underlying CPU for execution. You understanding? So why both the policies? I hope it is clear. So quickly with a diagram I'll try to convey you people. See, you can use any editor. Editor is a software through which you can create your programs, and you can save your program, you can open your old programs, you can make changes in it. So editor, you can use any simple editor like Notepad also, or some editors which Python organization only have given, or you can use any third-party editors also like PyCharm or Anaconda, Jupyter Notebook. So many are there, Sublime, and many are there. Clear? All have their good features. Okay, so any editor you'll take, and through that editor you'll type your Python code, you'll save it in a Python source file, which is with the extension .py. that is given to this impure interpreter, which is internally having a compiler. It will take that source code, find errors, no, convert it into a virtual code, a hypothetical code called as a bytecode. That bytecode is given to your Python virtual machine, which will line by line convert the bytecode into the native code, that is machine code, and then that machine code is given to the underlying processor for execution. And it is but obvious, like when you'll write program, you might be using something of the third party also, no? Everything you are not developing, something you might be using from some third person development, that is libraries also. So are these libraries also in a bytecode form? Obviously. So your bytecode is linked with that bytecode, and then it is converted into machine code, and then it is executed. So that is this interpretation policy. If you are clear with it, give me the confirmation so that the next two important terms we'll discuss. Okay? Or if you have a
Yeah.
question, you can ask me. Sure? Others also?
Yes.
Sure? Okay, very good.
Yes, sir.
So
Yes,
please
sir.
keep giving me confirmation. It gets, there has to be an interaction. Otherwise, there will be
Yes, sir.
just one side flow. Okay? Good. So this principle is clear to you, what Python follows. Then we'll discuss about the third important terminology, that is general purpose. Okay, generally languages are domain specific. Means some languages are specific for that purpose only. Like long back Fortran and all was there. Fortran is formula translation. Formula translation combined, and they made a word called Fortran. So Fortran is a language which is specifically for scientific calculations. Right? So some languages are only for file processing, like COBOL and all. COBOL is still used today also in SAP and all, like not purely that ABP BAN and all. There they still use COBOL. COBOL is specially created only for file processing. That is a language only created for file handling. So all these languages have their specific domain. Getting? Means some languages are only for graphics, some are only for scientific calculations, some are only for database handling, like SQL. It is only for database operations. So Python is not like that. Getting? Python is a language which is having all application areas. Now actually one area is not explored, that is mobile, but still these people are constantly in that development too. Getting? Means they are trying to explore that area also, but all other areas are explored. Means Python can be used for simple, you can use it for web development, GUI applications, graphics applications, then you can use it for network coding. Clear? That is socket coding. You can use it in data analytics. Abundant of areas are there where Python has not penetrated. Means it has actually penetrated nearly in every areas, and that's the reason we call it as general purpose. Means like if you are planning to develop a dynamic website, you can. You're planning to create just a standalone GUI applications, you can do it. You're planning to create network programming, you can do it. You're planning to create some hardware interfacing, okay, that is IoT, you can. That is Internet of Things, you can do it. So in short, what I want to say is, even in analytics, like now it has been used in so many areas, like share markets are using it, okay, all financial organizations are using. So nearly every area Python is used, and that's the reason it's called general purpose. And last concept I want to tell you, that is multi-paradigm. Now paradigm means they are the program design approach. Okay, means these are the way in which the programs are developed. Like some languages are just structured programming language, like old BASIC, if you have heard about BASIC and all, or those who have done shell scripting, like Unix shell scripting and all. So they are just structured scripting. You just write a sequence of code, like you accept input, you display output, you take conditional loops and all, but sequence of code, and it is just getting executed. So such structured script also you can write in Python. Procedure oriented code, like big task you can divide into smaller tasks. For each task you will write function, and then you will reuse those function. You can write object oriented code also. Data, functions, put it into a capsule, call it as a class, then create objects of the class, and then they can interact with each other. So that is multi-paradigm. So Python supports structured scripting, object oriented scripting, procedure oriented scripting, all types of paradigms you can follow. So if these four terms are clear to you, so now we can give a proper definition of Python, that Python is a high level interpreted general purpose multi-paradigm programming language. Getting? So I hope it is clear that Python is high level. Why? Because it is more closer to English. Interpreted. Why? Because it follows that policy. It takes the code, then converts to bytecode, and then that bytecode is line by line converted into actual machine code by PVM, and then it is given to the underlying processor for execution. General purpose. Why? Because it can be used in any applications. And multi-paradigm. Why? Because different programming approaches are there. Like you can write structured script, procedure oriented script, object oriented script, all. Okay, so hope the definition is sure clear to you guys, isn't it, all of you?
Yes.
Generally
Yes,
chat
sir.
window I don't see.
Yes,
Okay,
sir.
you can type it in chat window too, no issues. But normally I don't see, so if you unmute and if you tell it, good. Okay, now proceeding further, quickly we'll see the application areas which I have spotted. There can be many more areas too. Few I have spotted and I have found out. Okay, and by seeing these applications, at least you can think of what track to select in the future. Like if you're planning to do some career in Python track only, so you go in any area, you go to web development, IoT or data analytics, anywhere, initially you need to learn basic Python. So in all the tracks, first necessary thing is learning basic Python. So after completing that, then you can select which path to go with. Okay, so if some people are good in web development, you can select that track. Some are good in mathematics and all, so you can go to analytics part. Getting? Like if you're good in statistics and all, so you can select that path. So that is a later part, but at least you'll get an idea where Python is explored. So few areas I'll list out quickly. The first area is that is in the field of data science. Okay, now what is data science? Quick definition I'll tell you. Data science, you can say it's a branch of computer science where large collection of data is done. But now you'll say collection of data, so we do it in database management system also. So obviously that is a part of data science. But not only you're collecting the data. Data collection can be done by varied sources. Getting? Like through survey forms, then lot of things are there. Like through data entry, then manually the data is collected, so many places. Through sensors also the data come. So data collection is done. It is organized. Okay. Then on that modeling is done. Even cleaning is done. Like unwanted data is removed. Then the relation on that data is set. And after doing that, some scientific algos are applied. Algorithms. Okay. And using those scientific algorithms, you can find out some conclusions or inferences or some predictions from that data. Okay, now different algorithms are already designed. You people just have to put that algorithm in your data model. Like if your data is related to election, you'll put it in that way. So algorithms are already designed by people. It's so easy, like clear. Algorithms are already designed. Your task is to collect the data set and applying that algorithm. Getting? Like suppose you have collected the sample data from different areas of that state and now you want to do exit poll, election exit poll. So there also the concept of data science is applied. Getting? Even it is used in educational data. Like they want to do prediction for inclination of which stream students are preferring. Like are students less inclined now to medicine or engineering. So accordingly these educational institutions design new courses from that predictions. Getting? So in short, just remember data science, branch of computer science, where data is collected, organized, cleaning is done, modeling is done, and then different scientific algos are applied, and from which you can do some predictions from that data. Getting? And for that, lot of prediction algorithms are done. Then comes machine learning. Actually, remember, machine learning is used in data science. Okay, means data science is incomplete without machine learning, and machine learning is a part of artificial intelligence. Getting? By the human brain, you can realize from it. Here, in short, I'll just tell you what is machine learning. Like making your program behave like human brain. Okay, like human brains have the ability to take decision on their own, isn't it? By some past knowledge. We humans have lot of experiences, past experiences, and that get stored in our knowledge. And then whenever in future, if such problem come, do we recall that past knowledge and try to take the decision for that problem? Yes. Getting? So machine learning means developing such programs which are not to be controlled externally. Getting? Those programs will take the decision on their own only by the past knowledge. You understanding? A very simple example, like if there are thousands of images of cat given, and now suddenly one image of dog is given, so your program should have the capability to distinguish that this is not a cat, this is a dog, from the past knowledge. Getting? And always remember, machine learning is used in data science. Here, just in short, remember that here what is done. So such programs are developed which are taking decisions on their own from the past knowledge base. Getting clear? A best example, like chess playing and all. When you're playing a chess, so see, like initially when you are novice means you are just a toddler. You have just started learning chess, so you do lot of mistakes, but you start knowing it gradually, and as you go on becoming more and more mature, you start using those past moves in playing it. Same mechanism. Such program models are developed. Okay? Then comes natural language processing. Natural language processing, now to you have started using it everywhere. Okay, that is translation from one language to another. Google Assistant is there already. Google Translator also is there. So Python has developed so many libraries for doing this translation. Okay, so converting from one language to another, or from sound to text to sound, which 24 it should be approximately 25 to 26 years back when I completed my engineering. So that time in our final year, we had developed one project in C language. Just imagine converting Kannada newspaper to Hindi. So we used to give that Kannada newspaper to the scanner, and then it used to spell in Hindi. And all the libraries we had developed in C, it was a tedious task, which is few lines of code now in Python, because Python has already developed that libraries. There we had to do it. Just imagining, okay, the concept was too low level over there. All low level things were to be done by us. Here, lot of things already Python is providing. Your work becomes very easy. So here the conversion of one language to another. It can be text to voice to text, or one voice to another voice. All come in that category. Then comes network programming. Okay, that too in my life, first I did it in assembly, then I did it in C, then in Java, now in Python. So gradually the lines of codes are decreasing and decreasing. Getting? Like huge code in assembly we wrote, then in C pages of code. Java also at some level the code was bigger only, and then in Python it becomes 2 to 3 lines of code. Okay, so network programming means you can call it as a distributed coding, where two Python programs are present on two different machines, physically two different machines, which can be connected with wire, without wire, and then these two programs Python program which are present on two different machines are communicating. Means they are sending something or receiving something. One is a server role, one is a client role, which we also call it as a socket coding in other programming. Here also we call it as socket programming. If you have done socket coding in C or if socket coding in Java, so you will very easily understand it in Python too. Okay. Then web development. Web development is also very well explored in Python. There are so many frameworks already available, like Django. Okay, don't call it as Django. D is not even silent. Okay, the spelling is Django, but you should not call it as Django. It's just Django, a Romanian language. They have to write D. Getting? It's a Romanian word, but the D is not even silent too. Okay, so Django is there, Flask is there, Web2Py is there. So many frameworks are there, and those frameworks make the dynamic website development so easy. Getting? So if you learn at some time, if you get chance to learn Django, you'll come to know. Okay, automatic the dashboards of admin dashboards and all, automatic generated. Your class get connected with the table. You don't have to write code also for that. Getting? You create a class for your table. In backend there is a table. By default that is called as ORM concept. So that is also already developed in Python. So web development is there, database programming, like you can write Python scripts with which you can interact with some database management. More than 40 different databases you can connect in Python, including structured and unstructured, like including SQL base and no SQL base. You can connect with that script, you can send the queries, collect the result, process it, show it to the end user. Getting? Then IoT, I haven't explored yet, but I know that Python has penetrated in Internet of Things also. Actually, here there are some ready kits available, Raspberry Pi and all, and on that kits you write program, and through that you can control different electronic devices like home security system, your TV or your AC, everything you can control through your cell phones, and for that you can write such programs. Okay, but here obviously some hardware interfacing is needed, and even in cybersecurity also lot of scripts for cybersecurity are written in Python. Clear? So few application areas I found, there can be many more areas, but I think these are the more highlighting one and prominent areas where Python is being used. Getting it? And for doing all this, already Python has developed libraries for it. Okay, so hope the area application areas are clear to you guys.
Yes, sir.
Sure.
Yes,
okay.
sir.
Okay, good.
Yeah.
Okay, nearly all are interacting. Good. Now few joined later. I guess Aditya, another Aditya joined later. Okay.
Yes, sir.
Okay, no issues. Then quickly we'll see the features of Python. Okay, little bit theoretical, I'm sure. First session will be theoretical concepts like features, then history, and then we will dive into programming. After that, continuous programming only will be there till the end of the course. Okay, I'm sure, I'll guarantee you, you will enjoy learning Python course. Okay, so quickly we'll go through features of Python. Okay, the first feature, Python is simple and easy to learn. Why it is simple? Because they have tried to keep it more closer to English, right? So as they have tried to keep it more closer to natural language, and one more thing, they have tried to remove lot of unwanted things which were there in the ancestor languages. Getting? Not unnecessarily things are needed. Like they say, when you can do if else, why there is need of switch case? So no switch case. But now in 3.9 they have added 3.9, which is the latest version of Python. They took a survey from people, and some from that survey, lot of reviews came that switch case should be there in Python. So now in 3.9 they have introduced. Okay, so what is the syntax of switch case in Python, that we'll see. But that is a 3.9 feature. Before they were saying switch case is not needed. Getting a lot of unwanted things like no access specifiers like public, private, and all. Nothing like that they have provided. Then limited data types, okay, limited operators, and obviously because of that the language will become simple only. And anything which is simple, obviously it is easy to learn. Easy to learn. Why? Because the syntaxes they have kept it so simple, no confusing syntax. Okay. Second, it is freeware and open source. Okay, these two terms are used in companion, but they are two different terminologies. Okay, what is freeware? So to use Python, you don't have to purchase anything, no licensing mechanism, which for a lot of Microsoft products. But obvious, Microsoft products are all closed source. Now they have started giving it, but to some extent. Now if you want advanced features, then you have to buy it. Okay, not like that. Python is freeware. Okay, so you go to Python's official website, you can download it and you can start using it. There is no concept of license and you have to pay for it and purchase the licensed version and all, nothing like that. It's freeware. And now the trend in the software programming is moving towards this only, that is freeware. And open source means they are providing that Python distribution along with the source code. It's not closed source. Like Microsoft products are all closed source. They give you directly exe. You just have to install it. You don't get the original code. You just use it. Here it's not like that. If you go to official website, from there when you download the Python distribution, it comes along with the source code. If you are competent Python coder, you can see their distribution, make changes in it, and again you can give it back to the community. Means open source is for the community and by the community. Getting? Means no, you are not supposed to make money from it. Getting? So they are giving it along with the source code. Like Linux. Linux operating system is the Unix open source version, freeware. Unix is never free. Getting? But Linux is free. Linux is the distros, or you can say distributive OS of Unix. It looks like, or the internal kernel is same like Unix. Okay, but Linux is freeware and it is open source. If you read Robert Love's book, in which he has given 10,000 lines code of Linux, and if you are a C coder, you can study that and you can make your new OS also. You can design your own OS. Getting? So why it is? Because it's coming along with the source code. So freeware, no need to purchase any license. It's available freely. Open source, because it comes along with the code. You can study that code. You can make changes also in it. That is the main benefit. Okay. But normally people are least bothered. Maximum people are just interested in learning Python and developing new applications in it. They are not bothered about modifying what they have provided. Okay. So that is the second feature. The third feature, it is high level. Okay. Which already in the definition of Python I have told you, it is high level, meaning it is more closer to English. As you express anything in English, conditional thing, you write, if this, then I'll do this, otherwise I'll do this. Same way you'll write in program. Or I'll do this till this condition doesn't become false. I'll do this for this much number of time. So as you express it in English, you are going to express your program also. That's the reason high level. Okay? Then platform independent. Okay. Now what do you mean by platform independent? So your source code will never change if your platform change. Getting? Like if you are writing a Python script for, now if suppose this is the whole system for Windows, and the same mechanism, the Python interpreter for Linux is also available, for Mac also is available. They have developed it for all. Means PVM, Python virtual machine, will be for Windows also, PVM will be for Linux system also, and for Mac system. Okay, now what I want to say is your source code never change if your platform change. Like if you have written a Python script for factorial of a number, the same script for Windows, same script for Linux, which is not necessary in other languages. Like a best example is C or C++. You have to make some changes if you are running it on Windows. You have to make some changes if you are running on Linux. Some libraries change, getting the library files change. It happens. Okay, this is not the case. So your source code remains same. Okay, irrespective what your platform is, whether you're going to run it on Linux, you're going to run it on Windows, and that's the reason it is called platform independent. Clear? Okay, next is portable. Now portability, many people confuse this and this term same only, or they interchangeably they use it. They think this both things are same. Portability means what? Portability comes here in this byte code. Getting? What they say is, if your source code is same, your bytecode is same only, irrespective where you have compiled it. Like if it is compiled on Windows, if it is compiled on Linux, doesn't matter. The same bytecode will get generated if your source code is same. And now this bytecode, you can give it to any other system PVM also. Getting? Like you got this bytecode on Windows and I'm giving to Windows PVM. Windows PVM will convert it into the native code of its system and give it to the CPU. But if the same bytecode I give it to the Linux PVM, still it will be able to convert it. Now Linux PVM will take that bytecode, convert to machine code and give it to its underlying CPU for execution. Vice versa, this bytecode I can give it to that PVM also. And that is portability. Portability means what you can understand. Portability means the same program can be run on any platform. Getting? No need to bother about the platform. So portability meaning compile once, correct? Once. Now as I'm doing it with a mouse, so little bit the handwriting you have to manage it. Okay, it's not an offline class to where I write on the board. Okay, so you have to manage it. So compile once and run anywhere. Here properly, anywhere. Meaning I can take that bytecode and give it to any system PVM. The same bytecode I can give it to Mac PVM also and it will be able to run it. That is portability. Clear? So portability mechanism, I hope you got it. So Python supports portability. They say that you can run the same Python code on any platforms. Okay, you can give it to any PVMs, or you're compiling on one system, generating the bytecode, giving it to that system PVM. But if I give it to some other system PVM, still it will be able to run. Because these Python people, those who have developed Python, they have given PVM for all systems. Like JVMs are available for all systems, PVMs are also available for all systems. Getting? So please don't confuse between platform independency and portability. Platform independency means your source code will remain same, irrespective of any OS. And portability means you can run the same bytecode on any systems. Means compile once and run anywhere. Getting? That is the principle. Dynamically typed. Now again, here in any of this feature, if you have doubt, please ask me. Okay? If you're not asking and if you're not having doubt, I'll have an impression that I'm teaching extraordinarily. Clear? If there are no questions, so please ask question. If you have doubt, please ask. Okay? Or if these are all elementary things for you people, it's okay. We'll proceed with the next thing. Okay? So till here, I'll take some pause. Just give me confirmation. Till here, if you don't have any doubt, then I can move with the next feature.
No doubt, sir. All clear.
Sure. Okay. So very good. So we'll move on to the next feature, that is Python is dynamically typed. Little bit explanation is needed. Okay. Because generally from the background which you have come, I'm sure you people have learned C, you have learned C++ or Java. So their genre is different. Clear? Those languages come under static type family. Static type family. Meaning what? Okay, in those languages, you cannot use any variable directly without its declaration. Like I'm directly writing x equal to 10 is not allowed. You first have to declare it, and when you're declaring, you have to announce its data type. Getting? So once you announce it that it is of type integer, then it is forever integer till its lifespan. Lifespan means scope, so, or the extent till which the use of that variable is valid. And when the extent is over, it is died. So after that, the use is invalid. I hope you know that. So concept of scope we'll be learning in chapter 3. Don't worry. So you have to declare the variable. When you are declaring means you are announcing the name, its data type, and then you can use it. You cannot directly use it. And once it is announced of some particular type, like it is integer, so in its entire lifespan, it is integer. Getting this concept our Indian politicians should follow, isn't it? That is a sarcasm, but like our Indian politicians should follow. Okay? Once they enter in X party, so till their death they should be there only, isn't it? But the scenarios you can see, they keep changing their parties, right? According to the situation, according to the convenience, they keep moving from X party to Y party, Y to Z, clear anything. Some people in every election they are in different parties. Okay, so anyways, jokes apart. Here, what I want to tell you, Python follows that principle. Means Python follows our Indian politicians' principle. Like in Python, there is no need to declare variable because Python come under dynamically typed language. Means in Python, all variables get created runtime. How they get created, how symbol table is managed, how memory allocation is done, all will be learning. Don't worry. At this moment, just remember in Python, no need to declare variable. The moment you assign any value to the variable is created. And what type of value you assign, that is its data type. And actually it's an object. According to Python, everything is an object. In Python, nothing is without an object. Like in Java, at least we have 8 primitive data types. 8 primitive types which are not object. Here everything is object. So I'll not go into too detail now because when we'll come to programming, we'll be learning that. Now I just wanted to tell you the feature dynamic type, meaning you just assign the value to the variable is born, variable is created. Don't bother about declaration. And what type of value you assign, that is its data type. And the surprising thing is, after some time, if you are assigning some different value, like I'm writing double quote ram, okay, which is string, now it is a string object. Now it's an integer object. See, the same variable now is changed to string. It is like an chameleon. Chameleon in Hindi we call it as girgit, or in Marathi we call it as sarda. Clear? These common 3 languages only I know. I don't know other languages. Okay, so I can relate in these 3 languages. So as you know the chameleon, or we have girgit or sarda, who changes his color according to the situation, right? The same thing here, the variables are like that chameleon. Clear? What value you assign, that is its data type. That is the speciality. Okay, so dynamic type meaning what? I hope you got it. It is a loosely typed language. It is not a strict type language like C, C++, Java. They are strict type. Once you declare a variable int, throughout its lifetime it is integer. No such rule. So it's not a strict type, it's a loosely type. Okay, it is not a static type. Static type means at the compilation time only you tell the data type, and then at runtime it has to follow that data type. Not like that. Runtime the data type is decided, and that's the reason it is dynamic. Getting? So I hope this dynamically type, why we should call it, because Python says no need to declare variable. You can directly start assigning the value, and what you assign, that is its data type. And the moment you assign, the variable is created. Getting? Its entry is done somewhere. We'll be learning that too. Okay. So dynamic type is clear to you, and nearly all scripting languages are dynamic type. Like if you know something of PHP, so PHP also come in this category only. Okay, PHP is also the same thing, or Ruby. Okay, if you have heard about Ruby and all, so that is also in same category. Okay, then coming to the next feature, which at the time of definition of Python I told कि Python is supporting procedure oriented coding. Procedure oriented coding means you can define your problem statement into subtask, and for each subtask you can write a function, and then you can call those functions. Getting? Object oriented coding, like you can create a capsule in which you will add data, methods, and then you'll create copies of it called objects, and then they will interact with each other via methods. So that is object oriented paradigm, procedure oriented paradigm, both are supported in Python. Getting? Then Python is interpreted. This also no need to tell you again. We write a Python script, then give it to the impure Python interpreter. Internally there is a compiler which will convert it into bytecode. Bytecode will be given to PVM, which will convert it line by line to the native code, and then that native code is given to the CPU for execution. Here also there is a principle called JIT. JIT concept as is followed in Java also. .NET framework also follow. JIT means just in time compilation. Getting? Means again and again needed bytecode. It will not convert it every time to machine code. It will convert it once only machine code and use that machine code. So that JIT, just in time compilation, Python also follows. No? Then extensible and embedded. Now what do you mean by this? So Python allows you to use any other native language libraries also. Like languages which are converted into native language. Like C, like C++. So those libraries also you can use in Python. That is extensible. And as you are using those libraries and adding in your script, therefore I am calling it as embedded. Clear? Now even Java also they are supporting. Like you can pull Java libraries also into your Python script. Concept is there in Java too. Like in Java you can pull C, C++ libraries in Java. That is called a Java native interface. Same technique here also. So Python says if you have already developed something in other languages like C or C++, and you want to use those libraries in your Python script, you can. Getting? That is this feature, extensible and embedded. Getting? And the last important feature, Python comes with thousands of library functions already developed. Your task is to do intelligent selection of those library functions in your script. Don't waste your time in developing those functions. Python says we have developed so many things. Why you are wasting your time in doing the same thing? Use our functions and you develop your other big applications. Getting? Means nearly for everything there are libraries. For string there are libraries, for mathematics there are libraries. Okay, even for dealing with arrays there are separate libraries like NumPy and all. For analytics there are separate libraries. So database connectivity there are libraries. Okay, for socket coding there is a library. So rich library, abundant of functions are already developed. They say please use our library in your application and you develop something new. Don't waste your time in developing the same thing. Getting or no? Clear? This you can relate it like old days, um, our generation. Now there is at least 23. My teaching experience is 23. Before that, 4 years of engineering. So there is nearly one generation gap between you people and me. Okay, but what I want to say is that time our moms, when there used to be a birthday party at home, she used to prepare everything on her own, everything on scratch. Like if for birthday party there is idli, sambar and chutney, so that batter of that idli also she used to make, batter of that idli, and then idli was prepared and then she used to arrange on the table for birthday. Then middle age moms, like middle generation moms, they a little bit smarter. Batter they used to bring from market, and idli preparation they used to do, but batter from the market. And now the modern moms are so uh, uh, intelligent. They even bring idli also from the market. They just arrange it on the table for party. I hope you are relating it. Getting? Like if you go to DMart, okay, so DMart, everything is there in DMart. Star Bazaar, Big Bazaar, everything. It's your choice. Pick it, put it in your trolley, and you have to purchase it and come and use it. You don't bother about how it is developed. Everything is abstract for you. You are just using it in your work. So, as I said, na, ki modern moms, if there is a birthday party at home, they will just order it. Swiggy, Zomato, everything. It will come. Only arrange it and do the party. Getting or no? So, lot of things are abstract, already developed. You are using it in your application. Exact same Python says. Python says abundant of functions we have developed. Please use our function and achieve your task. Getting? So I hope all the features which I told you, quickly I just told you all the features, but all the features clear to you guys. Okay? If any query in any of the feature, you can ask me. No? No.
No.
Okay. No problem. Very good. Then all of you have, mainly you have understood everything. Okay. Then coming to, quickly we'll just see history of Python. Okay. Now, in short, I'll tell you, because I'm sure history you people are least bothered, or it's not a liked topic, right? So just in short, quickly I'll tell you who invented Python and when. So Python invented by Guido van Rossum. Okay, Guido. How you pronunciation is up to you, because it's a proper noun, but normally it is called as Guido van Rossum. So he developed Python in late 80s and early 90s. Means around 89 he started, and then in around 90 and all it was available to people. And remember, Java is being developed after it. But then many people say like, why Python has now come into form? So because they have developed so many libraries which are in different areas like machine learning and all that. So it has got a red carpet now. Okay. So in late 80s, like around 89, it started development and officially available in 90s. So late 80s, early 90s, it was developed in National Research Institute for Mathematics and Computer Science, Netherlands. Getting? So Guido used to work there. Now he has joined with Google also. But he used to work there, and in his Christmas holidays he developed it. So in Christmas holiday he was getting tired and he was not thinking what to do. So he started designing a language, and he came with a language, and that time he was not knowing that in the near future it will have so much of popularity, which now you can see. Okay, so he started developing by taking lot of ancestor languages like C, C++, Simula, Smalltalk, Ada, Algol, ABC, then Unix shell script. From all these languages, he took all the good features from all these languages and he developed Python. Getting? But now again, many might be having a curiosity question: why name Python? Okay, is it related with the snake Python? So no, he was very much fascinated with one comedy show which was broadcast on British channel, BBC channel. Okay, and that show name is Monty Python's Flying Circus. It's a famous comedy show. Okay, so Monty Python's Flying Circus, and he was fascinated with that show and he dedicated his language to that show, and therefore he named it as Python. Getting? Same like Pascal. So Pascal is a mathematician. He is nowhere concerned with programming. Nicholas Wright, when made Pascal, so he was fascinated with Pascal. Therefore, Nicholas Wright gave his language the name Pascal because he used to like Pascal's work, mathematics work. So that way, Guido devoted, or he gave Python from that comedy show. That is from Monty Python's Flying Circus. So now it is being managed by a very big team. There is other team members also in Python development, but still Guido is the important role player. Okay. So in short, I just told you, okay, it is Python is developed by Guido van Rossum, late 80s, early 90s. I told. Okay, developed at National Research Institute for Mathematics and Computer Science, Netherlands. Clear? He is Guido. Okay, and as I said, he derived it from many ancestor languages like ABC, Modula, C, C++, Algol 68, Smalltalk, Unix shell script, and other scripting languages also. Okay, and he named it Python. And as I said, he was tired at home in the Christmas holiday and he started designing, and within one day he came up with a parser also for that Python. But obviously that time Python and now Python, massive changes, abundant of changes have taken in today's Python. Okay, so name Python because he was fan of Monty Python's Flying Circus. It's telecast on British channel. Okay, and it is being maintained by one core team at this research institute, but still Rossum is the role player of that team. Okay.